The mitral valve, named for its resemblance to a bishop's mitre, sits between the left atrium and left ventricle. This valve's function is to prevent the backflow of blood during the ventricle's contraction phase, thus ensuring a unidirectional flow vital for efficient cardiac output. The mitral valve guards the left atrioventricular orifice. Smaller than its right-sided counterpart, this orifice serves as the critical portal through which blood transitions from the left atrium to the left ventricle. The mitral valve is also named the bicuspid, and it has this name because it has two proeminent leaflets. The first leaflet that we will look at is the anterior leaflet. It is the larger and more prominent leaflet of the mitral valve, and it is strategically positioned between the atrioventricular and aortic orifices. It functions as a shield, coordinating closely with the heart's rhythmic contractions to regulate blood flow. The second large leaflet of the left atrioventricular valve is the posterior leaflet. Smaller in size and situated posteriorly, it complements the anterior leaflet, ensuring that the valve's closure is secure and complete. At the junction, the anterior and posterior mitral valve leaflets are continuous at the commissures. When the valve closes, this continuity becomes more pronounced, and the commissural leaflets become visible. These leaflets facilitate the seamless operation of the valve. Similar to the tricuspid valve, the mitral valve opens during ventricular diastole to allow blood from the atrium into the ventricle, and closes during ventricular systole to prevent backflow into the left atrium. The mitral valve, as the tricuspid, is surrounded by a fibrous ring or annulus. This ring provides the architectural framework that maintains the mitral valve's shape and integrity. It anchors the leaflets and ensures their correct alignment. Similar to the tricuspid valve, the mitral valve is tethered to the tips of the papillary muscles via tendinous cords, known as chordae tendinae, that anchor the valve leaflets. Their primary role is to prevent the leaflets from inverting under the pressure of ventricular contraction. These cords are systematically organized, with some attaching directly to the leaflet's free edges and others to their ventricular surface. This strategic arrangement enables the valve to withstand the intense pressures of ventricular systole. During ventricular systole, the phase of the cardiac cycle when the ventricular muscle contracts, the mitral valve closes firmly. This action is crucial as it prevents the backflow of blood into the left atrium, ensuring that the blood is efficiently propelled forward into the systemic circulation. In contrast, during ventricular diastole, the relaxation phase of the ventricle, the mitral valve opens to allow blood to flow freely from the left atrium into the left ventricle. This opening is essential for the heart to fill with blood, preparing it for the next contraction phase. This concludes our exploration of the left ventricle. Next, we will delve into the pulmonary valve.